This conference will now be recorded.
And
Thanks,
we
Siri.
can start by saying myself, Nathan, Tyson Williams, who is in his dark room over there, and Alex, who is very close to the camera. We all really appreciate discussing technical things. And recently we've been talking, or you guys, I guess, have been talking about F# testing, and specifically FSCheck and HedgeHog. So Tyson, you follow Mark Seaman, you really like him, and you really thought his blog post was really interesting based on this discussion. So do you want to maybe kick us off and tell us why this blog post is something that we need to discuss?
Yeah, so this the most recent post by Mark Seaman is called Dynamic Test Oracles for Row Problems. And I find it interesting for the general reason that it's related to property-based testing. He generates random inputs during this process, and he uses a property-based testing library called FSCheck to do that. The really interesting thing at the end is, okay, I have to talk about more details first.
You might want to start with the definition of a row problem.
I'm interested to know what led you guys to, like, how did you get to this part? I want to talk more about why you and Alex find testing so interesting, and specifically property-based testing.
Okay. It's very easy to write bad tests, and a lot of people do that. I used to do that. The main reason you write bad the main thing that's bad about tests is when the tests are impure. When it has some side effect, it writes to the database, it writes to a file, it reads from files, although reading from files is not as bad as other things, but they're all these impurities are not so good. Mutating, not all mutations are considered impure, but roughly speaking, mutating like global state or static state, all these things make code hard to test. Test-driven development came out of the dynamic programming language community, where the compiler had less, well, there's no compiler, so they had nothing to like lean back on. And so like tests are more important to them than it is in the statically typed languages, strongly typed languages. And so they developed this test-driven development where one of the outcomes is you're guaranteed to have testable code. Your production code is testable by definition because you never wrote any code unless you had a test first that required that was already failing and you wanted it to pass. So that is a great goal, to write testable code. But here is like a secret or a shortcut that Mark Seaman and I agree on. He wrote a post called "Pure Code is Intrinsically Testable." The way I think of it is that you'll read some like testing books or testing literature, and very few people agree on names and terminology and what it means. But roughly speaking, a unit test is a test that runs quickly, doesn't have dependencies. Those are the main two things. There's probably more that I'm blanking on right now. But I realized one day, especially listening to Mark talk about this, that's a very, very high overlap with what a pure function does. So it's not a logically or mathematically exact statement, but first order approximation is exactly true, which is a unit test is a test of pure code. So when I started writing pure code, there's a sense in which, as Mark says, it was intrinsically testable. And that made for better test code.
Pause here and say what pure code is for people unfamiliar with functional programming.
Hang on, let me try, because I've heard you say it a couple times. So pure code is, I like to think of it as scoped in such a way that it doesn't have any dependencies and it doesn't have any side effects. So you know what goes in and you know what comes out. How close am I?
Pretty close.
My
The
understanding
main thing,
is that it has two properties. One is that it doesn't side effect, and the other is that it's deterministic. Tyson?
I worked very hard to point out to Mark Seaman that determinism is stronger than is needed for purity. Purity needs a slightly weaker statement, which is that the same input always maps to the same output. But it's allowed for the intermediate sequence of states to be different. Deterministic says that not only are the input state and the output state the same, but all intermediate states are the same as well.
So just to be clear, before we go down too far down this rabbit hole, I was trying to quote the Wikipedia definition, and I just looked it up, and it does not use the word determinism. It uses it's more in line with what you're describing right now. So yeah.
The example to keep in mind that I think it best illustrates this difference is the randomized version of quicksort. So quicksort picks a pivot element at random, uniformly at random among the elements, and then puts things to the left that are bigger or smaller, and then things to the right that are bigger, and then recurses. The point is, every single time you pass in the same input, you will get the same output, which is to say that array in sorted order. Don't worry about the mutation. If you want, it's fine. It can output it in a different list or something so that it's never mutating the input you gave it. So that's an example of a function which does not always, it's not deterministic. It does not have the same sequence of intermediate states because it uses randomness. But from the caller's perspective, it's pure because the same input always maps to the same output, and there were no observable side effects is usually the phrase, usually the adjective given.
And I believe you had used the word consistent to describe these functions instead of deterministic.
Yeah, consistency, yeah. So it consistently maps A to B. Like for the same value A, it always maps it to B. Like 1 always maps to 2, for example.
Yeah, I'm not finding a good word on the Wikipedia page, but consistent and no side effects are the qualities of a pure function.
Would it be considered a side effect if you passed in a variable that got mutated? Because I know mutation is also not pure, correct?
Some mutations allowed.
Some mutation.
Like if you write a function,
visible mutation is allowed.
Sorry?
That's why it's called visible side effects is the phrase.
No. Oh, yeah.
So if you write a function that takes a list of integers and returns their sum, if you do that by initializing some accumulator value, the total or whatever, to 0, and then you do a for loop where you're going to increment, like you could even have your variable I, or okay, in simplest case, you just have like a for each loop. So you have your value n from your list of integers, and then inside your for loop is the single statement, which is you mutate your accumulator value. After the loop is done, you return your accumulation. You have mutated the accumulator in your function, but nobody could see that. So you played with fire and got away with it. You're pure.
Another example of this might be when you're iterating over a list, you're mutating the pointer each time. And so, and most people will happily do that and not recognize that there's mutation going on. And that's fine because, as Tyson had mentioned, that's invisible mutation, and it's not going to be noticed by the caller, which is why when you pass in an argument and then you mutate it, you may change things for the parent, which is visible to them. So that is a side effect. and therefore not a pure function.
I see. So by visible side effect, what if the parent calls the pure function, the caller calls the pure function, and the pure function per se writes a file to the file system? Would you consider that a visible side effect?
Yes.
Even though the caller doesn't know that the file was written, it's still considered visible.
No. They can just guess. It's like non-determinism now. It's like you can just get like you can either the file system can be set up to like notify the caller just for any change at all, or it, it it's like if you're missing your keys, they could be anywhere and you have to just look anywhere. But if I tell you, I know that your keys are under this bed, like go look and find them, and then you find your keys, like how'd you know the keys are there? Doesn't matter. Like I happen to know that. You don't have to know. It's like a proof of existence. You don't have to know why I know what file to look at to see if I check before I call you, I check after I call you. Oh, it's there, so I blame you for creating it.
Blame you.
Purity takes discipline, and so it's something that the programmer, at least in C# and F# and the languages that we're familiar with, it requires a certain amount of fortitude from the programmer to say, hey, I'm going to make sure that this function is pure. In other languages like Haskell, if you're going to try and write to the file system or write to the console or side effect outside the or just try to side effect, you are going to run into the constraints of the language because they're going to force you to do that through some type of IO monad. And that is enforced by the language. C# and F# and other languages like JavaScript, Python don't enforce that, and so they happily allow you to side effect however you want. And so for us normal people, we just have to be aware of what we're doing. And so when you say a function is pure, you actually need to think about it as compared to letting the compiler tell you that it's pure or not. I'm speaking very loosely here, Tyson. Yeah.
Well, it sounds like maybe we should take some time separately and talk about pure functions.
Oh yeah.
But if we want to talk about specifically what we started talking about, which was the property-based testing, and this blog post, which I'll need to reference later. Go back into you spoke earlier about FSCheck versus HedgeHog and how you guys started your, we're all newbies, I'm going to say, within a couple years of F#. And, one of the great things we've learned about it is all the cool things you can do with testing with F# and pure functions. So Alex speaking for FSCheck, is that right? And Tyson speaking for HedgeHog. Talk about the transition for you, Alex, on how you figured out that, or how you allowed Tyson to convince you that HedgeHog was more appropriate for your scenarios.
I think there are some situations where FSCheck is still better. So as Tyson had mentioned, actually prior to the discussion, so whatever. FSCheck is faster for one. I have noticed that in at least a few of the tests I converted over, it's by an order of magnitude faster. So like tests that used to take 1 or 2 seconds now take about 10 to 15 seconds. That's something that I'm looking into and potentially might be a PR I'll make in the future. We'll see if I find the time to get around to doing that or find the wherewithal. It is more fully featured. It has integrations with XUnit and NUnit. I recently built out an extension for XUnit, like within the past week or two. So now we're missing integration for NUnit. But otherwise, the main reason to switch to HedgeHog is the fact that it comes with free shrinking, which basically means that since we're generating random data and we're throwing it at a function and then asserting that the output has a certain type of shape, those random values can get really complicated really quickly. So if you imagine a tree or like some type of recursive object that's being passed to a function, that tree can get really large and out of control. So like, well, I won't give an example. But let's say that a tree of depth 5 causes your test to fail. And now we need to shrink down that tree to see like, hey, is it really a tree of depth 5 that causes the problem, or is it like some number in that tree that causes the problem? And so what HedgeHog will try and do is it's going to try and make a minimal, create a minimal example for you to look at and understand and see what the problem is. And so a more realistic example, actually, someone wrote a blog post about this, is they were writing an email parser or an email software, and they ran into an issue with, I'll just call it a parsing problem for now. I'm not entirely sure if that's true, but whatever. And so they were trying to look at some data, and it was causing a problem in FSCheck. And the problem with FSCheck is that it doesn't come with shrinking for free. And so the random data generator like had more than 1,000 characters in the string it was throwing at the parser, and no one wants to look at 1,000 characters and figure out what's wrong with that, especially if the characters are like Unicode and have some Chinese symbols and Latin characters or whatever. It's not fun and it's no good. And so he converted it to that test to HedgeHog, and it shrank down that that test, the input, down to the fact that it had like a /r/n, like a new line character. And for whatever reason, that was causing the test to fail. And that's way more interpretable and way more easy than it is for in HedgeHog than it is in FSCheck. So that's a incredible advantage for HedgeHog there.
Yeah, but before you showed me that blog post, which I'll have to look that up and link it to, but I wasn't sure what shrinking was until I read that, and I saw the blog post. I thought, well, that's really interesting, because initially the error message that he was getting back was like, what, 100 or 1,000 characters, and he was having to parse that with his human brain, which I've done that and it's really annoying. But then converting it over to HedgeHog was able to say, okay, this 1,000 character string failed. What about this 999 character string? What about this 990 character string? And it was able to keep going down and down and down, which I think hints toward the performance issues. It's taking longer to execute the test because it's taking a significant amount of time trying to minimize those errors and really isolate what is actually causing the error. And I thought that was really interesting.
Mm-hmm.
To be clear, though, the runtime issue that he's talking about, you should only care about the time to execute. Like by default, HedgeHog picks 100 tests, 100 inputs to test. That's what you should care about for runtime. If it finds a failure, you should conceptually say, take as much time as you want to find me like a minimal solution, not as much time. But you don't care that much, because the point is it doesn't happen very often. Almost never are the tests failing. And when they do, you do want the computer to work really hard for you to find a very easy to humanly understand input.
Yeah. Sorry to break you up there, Alex, but I want to make sure that shrinking was explained.
Yeah. And so I didn't understand that first. So FSCheck can do shrinking. It just doesn't come for free. You have to manually do something to make it work. I haven't looked into it myself personally because I'm lazy and my tests pass most of the time. And shrinking usually
whatever. I've seen your tests.
You only need the tests. You only need the shrinking when it fails. And so,
right.
just like people who sort of don't do test-driven development, which includes myself, like you don't write tests for all your code, and then so you have like code without tests, and that's generally considered a bad thing. It's the same thing's going to happen here. People are going to write property-based tests without the shrinking capability when they use FSCheck. Like, that's my impression. From my little sample size of Alex and some other things I read online, like my impression is that people, and it also makes sense that this would happen, that people would write FSCheck tests They generate awesome properties. It proves things are great. Most of the time the test pass, you don't need the shrinking most of the time.
So is that it? I need to switch from FSCheck to HedgeHog just for the shrinking?
Absolutely. So you should definitely switch for that reason.
That is a reason. A second reason that's less important, but I find pretty nice still, is it has a cleaner API. There is a dependency injection container thing in FSCheck that is just weird. You like, actually, weird is a poor way to put it. I don't like it because it uses static state, and then you magically know that the arbitrary, they call it arb, ARB, contains the state, and you register stuff to it, and then it generates stuff. It's odd in a pure language or in a functional language, and it has an additional monad, the arbitrary monad, in addition to the generator monad, that's completely superfluous. You don't need it, and HedgeHog has only one, at least publicly visible. It only has one.
Yeah.
So yeah.
Only has one.
Roughly speaking, like this gen monad or arb monad. Roughly speaking, FSCheck has the gen monad for generating random inputs and the arb monad for shrinking. But HedgeHog, like the idea that was so, let me give the history briefly. So I don't know all the history of property-based testing. What I know is that what came first was a library called QuickCheck in Haskell. And then I also don't know exactly what comes next, but conceptually in my mind, what comes next is HedgeHog in Haskell, where they have this idea on how to combine the gen and arb monads into one. So they call it integrated shrinking. Again, somewhat intermixed possibly in time. Eventually, both of these libraries are ported over to F#, and now those are called FSCheck and either just HedgeHog if you're in the context of .NET or F# HedgeHog.
I actually didn't know what arbitrary was for, so okay.
I hadn't used it, but that's my impression, is that that's the point of the arb class is for the shrinking, and that's why you don't see it in HedgeHog, because they have integrated shrinking. It's the same thing. Gen does both things for you. Yeah.
And so like when I was converting my FSCheck code to HedgeHog, I literally just went through, changed a few of the keywords because some of the words were different, but most of it was just deleting arbitrary.
Yeah, exactly.
I deleted more code than I added, and it was great.
That's always a good sign.
Yeah, and so simplifying the code, and yeah, I'm pretty happy with it so far.
So I guess you referenced a blog post, which was dynamic test oracles.
Yeah.
How does this apply? Because I quickly, I looked over it, and he starts out with, test cases for Python, and then he talks about switching it over to F#.
Yeah.
So tell me how does what we're talking about apply to this?
Yeah, I'm gonna hijack this moment to talk and kind of actually answer a question you asked before, which is like why are property-based tests important at all? And I started by talking about pure code and then tests of pure code. So the reason I started there is because I felt like it was a game-changing experience to realize that it sufficed to write pure code and tests of pure code. Previously, I'm in like this object-oriented mindset where I have all these interfaces, and in .NET I use things like I'm not gonna remember this right off the top of my head. It's this dependency like mocking simple
and
something.
Substitute.
And substitute, yes.
Yeah. Okay.
I would use libraries like nsubstitute in order to expose the pure code that was weaving in with all the impure code. So it's like, you can imagine it'd be like every other line of code was either pure, impure, pure, impure, pure, impure. And in order to test just the pure parts, you had to do all this work in the test code to put in these fake things so that the impure parts were replaced with pure parts so that it wouldn't screw up your test.
Right. Yeah, I do that all the time.
Yeah, because you're doing it wrong. Or you just write code that doesn't have any impurities in it at all. And then when you go to test it, you don't have to do any of that extra work. Okay, so that realization in terms of like, that's the right way to write code was a game changer. In terms of from the perspective of tests, I mean, it's a good idea in general, but then from the perspective of tests specifically, it makes the test so much better. Okay, that's like order of magnitude 1. The next order of magnitude was realizing that because I always, even when I wrote these unit tests, these tests of pure code, I preferred and liked writing what people call parameterized tests, where I would like have like a few 1, 2, 10, not one actually, right? Multiple input output pairs. And I would say this general kind of thing should hold, like an X unit, instead of a fact, which is sort of like one thing is true, it's called a theory. It's like I have a theory about how this function should work, and it should have this kind of behavior, generally speaking, generally in the sense of like 5, 10 cases, something like that. A property-based test is like arbitrarily more. So for example, I wrote a property-based test. I wrote a function that finds the point of the intersection of 2 lines. And in order to check the correctness of the code, I wrote a property-based test that creates a horizontal line and a vertical line. And then I know programmatically what the intersection should be, because that's a very simple case, horizontal and vertical lines. And that should be the answer to the test. And then I had the code, it runs 100 times each time the test executes because of HedgeHog. Writing your code so that you can test it with a property-based test is like another order of magnitude jump in my mind, in amazingness and awesomeness. The point, in the same way that you're like, if you just think from the perspective of test code, because as programmers, like, let me back up another thing. I used to think when I started programming that test code was like a second-rate citizen. I used to think that you shouldn't change the production code for the sake of the test code. I don't know why I thought that. I have Googled around for that idea expressed explicitly. No one says that. I feel like it's just in the air that this belief exists. Have you seen it, Alex?
Yeah, it's called test-induced damage. It's a sentiment expressed by someone, Heinemann.
I've heard that phrase too.
It's like from the creator of Ruby. Yeah, DHH. So he's a pretty famous person because he wrote Ruby on Rails or something, or he's big. I forget exactly what he did. But
I mean, it makes sense because the test code doesn't actually get the work done. So if you're in an institution where you're under a lot of pressure to make the application actually do work, your tests don't actually make the application do work. So I think that it makes sense intuitively.
Yeah, of course, the whole point is that the tests are in some sense like the foundation on which your production code is correct, because your client doesn't just want fast code or something. They also want correct code. They want it to do what they're paying you to make it do. Now, of course, I'm not throwing you under the bus or anything, Alex, right? But the phrase test-induced damage is like a self-fulfilling prophecy here. Of course, who wants their test to induce damage to the production code? Nobody's raising their hands on this, okay? But the point is, maybe the tests can cause the production code to change in a good way. But I'm saying my impression was that you shouldn't change the production code for the sake of the test for any reason. So it's like a stronger statement than this test-induced damage claim. I do agree that there exists test-induced damage, but I'm saying, like, I used to think it was like in a sense that like all test code changes on production code were like damaging in conceptually. I felt this. I don't know why I thought this, but then I forget who taught this to me. Like, where did I learn this? The point is that your application has many users, like exposes many APIs, and one of those is to your users of the application in possibly various forms, and one of them is the tests. The tests are a first-rate citizen. The test code is not second-class code. You should take as much care and put as much effort into the test code as you do into the production code. It's not second-class citizen. So I'm saying, so now that you care a lot about test code, it's like, think about your production code from the perspective of your test code. Initially, you were writing this impure, like, object-oriented style interfaces everywhere, and you had to put a lot of effort with things like n substitute or your own fakes and mocks in order to get anything done, anything tested in any consistent, useful way. And you had to spend an enormous effort just on the test code. The reason you were spending a lot of effort on your test code is because you didn't write the production code in the right way. If you would have wrote it as testable, then it would have been easy to test by definition. But how do you make the test code testable? You should write pure code. Pure code is intrinsically testable. Again, the title of one of Mark Seaman's blog posts. So now, don't just write pure code. Write code in such a way that you can test it with properties. Now, of course, not all code has like a property that you can test, in the same sense that not every single piece of code that you're gonna write in your production code is gonna be pure. But the point is, just as you try to minimize the amount of impure code and maximize the amount of pure code, do the same with properties. Maximize the amount of pure code that has properties, minimize the amount of pure code without properties. Not to impure code, but to property code.
And by property, I'm guessing that you don't mean a class property.
No, the classic example of a property is that the reverse function of a list is its own inverse. So given a list, the reverse of a list is the same as the list itself. If you write
another
a function,
example, yeah, like you also gave another good example with the intersection of two lines.
That's true. Yeah. Yeah, the map property is more like a mathematical property, like or you might even say it's like a statement in first order logic.
Mm-hmm. And I'll give another example.
Inputs and outputs.
I see. So it has no relationship with class properties.
That's just a coincidence in the name.
Right. Okay.
So to kind of talk up pure code for a second, when I was writing my XUnit project, I had like the principle drilled into me. I made everything as pure as I could, but I was running into a problem where my tests had to fail, because when you're writing a testing framework, you want to test that you want to test behavior where the test fails, right? So for example, let's say that you have a fact attribute on a test, and you have inside that fact attribute, it throws an exception. You have a failing test. I want to assert that it fails. How the heck was I going to write a failing test that would pass CI/CD, right? And so on top of this, I was also like, the attribute that I was writing would be providing random data to the method. And so that's the actual behavior that I was testing then, and generating that data might sometimes cause an exception, right? And so how was I going to write a test that could pass? Tyson had the answer for me. My code was already pure. So what I could do is in XUnit, you can add a skip attribute on your test, and so it won't actually be run by CI/CD. And so then I would have the test that's decorated with my property attribute, and then I would have the real test, the one that CI/CD would run, and that would be decorated with the fact attribute. And so from that fact attribute, I would call the test method via reflection and say, hey, run this test inside a safe container. And I know that I can do that because reflection is amazing. And then it worked. And it was actually really neat. So like I have a property that's being skipped alongside a test that's actually running it via reflection. And so I can have tests that fail but still pass CI/CD. So that's really nice.
So the way that I've handled that in the past is I make the test sort of lazy in a way, and then you execute the lazy function or whatever you have inside of an assertion where you assert that it throws an exception, or you can wrap it in some sort of try catch container. So where am I at here based on what you're talking
So
about?
I couldn't quite do, so what happens, like, let's say that inside the body of the property, you have, you do the raise exception or throw exception of some message. That isn't quite what works, because what I do is I take the entire expression, the entire method, and I am going to I'm going to call that method with different types of input, right? Because that's how a property-based test works. And so it's going to be throwing random data at your method, and it's going to run that method in various iterations. And so if that test fails, it's going to fail. And so I can't put it inside of a in X units. It's like you assert exception, and then you say the type of exception, and then the specific error message that's going to come out. I can't do that because it's not throwing an exception, and that's what I need, because, like, oh, also because I also wanted to test the shrinking, right? And so in order to shrink, an exception must be called. So like, for example, in one of my tests I had throw exception if the input is larger than 10. So it would grow to 10, get to 11, fail, try to do some shrinking, and then realize that 11 was the minimal case of the exception occurring. So in order to test the shrinking, I had to have HedgeHog realize that an exception is being thrown. So there must be an exception. It must be registered by HedgeHog, and in order to do that, I needed to separate the test from the test calling it. If that makes any sense.
Sure. So I obviously helped you with this, Alex, but I want to understand as you explain it now. Are you saying that you put the skip attribute on a test because you use that to test, like, from a human perspective? Like, you would comment out the skip and you would run it just to see it have the right behavior, but most of the time you keep the skip attribute, like, commented in, and your CI is testing the pure part that is the core of that algorithm?
So what I did is I would have skip on the method that was being on the property-based test. So I wasn't actually the XUnit test runner was not actually calling the that test. Instead, it was being called vicariously through another test that was decorated with fact. This is not a property-based test. And what that fact did is it would use reflection to find the property-based test by using the name of operator. So I would give it the name of the property-based test that it was calling. And then it would use reflection, grab the method info, and I'm using quotes there because that's what it's called in C#. It's in reflection, it's called method info. And then provide that method info to the pure class, to the pure function that I had written in F# in my main test code. And given that method info, I would generate random data and then feed it to that method info, use reflection to invoke it, grab the data, and then see if it had a certain shape to it, then throw or not. Does that answer your question?
So to be a little clearer, so like what I told Alex is that HedgeHog has a function called something like generate report or report. The point is that it gives you back a record, a data structure, which tells you what happened. It says the test passed or failed, and if it passed it, I think it tells you how many tests it ran, and if it fails, it also tells you how many it skipped. If it failed, it tells you, like, how many times it was able to shrink before it stopped. Like, it gives you this full report in just a data structure with a bunch of ints, essentially. And so I'm like, Alex, when you test your attribute, you should just have it just test that part, only call that part of HedgeHog. So what happens inside of HedgeHog is that function is called, this very pure function. It just returns this data structure. And then there's like a function very close to the top level of HedgeHog, which looks at the report, and if it fails, it throws an exception. So that part's the hard part. Like this record is a very strong type. Throwing an exception is a very weak type. So don't wait until it's a very weak, hard to understand, hard to test for equality, hard to see thing going on. Do it when it's like this very visible, easy to test, easy to check type.
Yep. And so like originally I had my inside the fact, I did have the assert exception from XUnit being used to say that the error message is going to look a certain way, because only using assert exception could I say that, hey, the shrunken value is now 11, or the minimum value causing an exception is 11. But when I am given a report, a class, a value instead, that's much easier to assert against, rather than just having to assert that the exception message is blah. And it's also like way less delicate, because it's the exception message is actually changing in the most recent version, 0.9, because we are adding more info to it. So, but we are not. But my test will now work in that new version, because I am not asserting that the exception message looks exactly like something.
That's called a brittle test, right? His test is, it's similar in AI, in like machine learning. People call it like overfitting the data. His test was brittle because it was too specific. He doesn't actually care, Alex and his attribute don't care that this is the precise error message that comes out. He just wants to know that it failed. So don't wait until that report is turned into an exception and a message and thrown. That's too late. That makes for a brittle test. Do it earlier, it's clearer and robust.
And so to be clear, like I care about it failing and having a particular shrunken value, because that's something that
yeah,
I had,
and that's in the report.
Yeah. So yeah.
So Nathan, it's not like some people will disagree on whether a pure function is allowed to throw an exception. The strict people, just the people who are more strict about it, and I'm in that set, say that a pure function is not allowed to throw an exception.
Right, because exceptions are side effects.
Or
because they don't have return values?
Maybe, I can't remember. I'm actually writing a post about this. It's a very, very long post and very detailed, so it won't come out for a long time, but I have a very, very long draft right now. And I actually somewhat forgot what I said, so I'll have to double check.
Okay.
But
well, after you come out with it, let's discuss it.
Yeah, it's a very long one.
Okay.
Okay. So now we can get more on this blog post now. So now that you have
now we're starting.
Now we're finally starting. So here's another idea. A function has a measure of complexity called cyclomatic complexity. Conceptually, it's the number of different paths through this function. It is, if you want to test this function, there's a sense in which you need at least that many tests, at least as many tests as the cyclomatic complexity, because you want to test at least each branch in this function. This function might call other functions which branch a lot, but right. you're not penalized for that. Now, so in that sense, like, go ahead.
When you explained that to me one time, you explained it simply in saying, essentially, if there's an if statement or something like an if statement, but let's just say an if statement, an if statement changes the path of your code or changes the result in some way, then now you have two branches of complexity instead of one branch of complexity.
Yeah, that's right. So yeah, so if you don't have ifs, don't have for loops and such things, you go straight through, then it's just cyclomatic complexity 1. Okay.
So just out of curiosity, does a for loop and a while loop introduce two branches? Because you have the branch where there is something inside of it, and there's the branch where there isn't something inside of it, correct?
Or
is it more complicated than that?
I think it just goes up by 1, yeah. I mean,
okay, all right.
I say by 1. It might be this like, I think it's more like it multiplies by 2, right? So going from 1 to 2 could either be because you added 1 or you multiply by 2. Like imagine you're at a single point and it forks like this and comes back together again. And then it forks again and comes back together again. Each time you multiply by 2 to get 4 paths through the code. right, right, left, left, right, left, left, right. So each time there's a branch, you're actually multiplying the complexity by 2. I'm not saying it's always a power of 2 either. Like you can have more like you can, for example, have a 3-way split or something.
Yeah.
Okay. So you have each function has cyclomatic complexity, which is like a lower bound on the number of tests that you should have on a function. Roughly speaking, people will call, if you're given some set of some function, like this is the perspective you usually see it in. It's like you're given some code that doesn't have any tests for it already, and you want to try to understand this function. The first thing you should do to be safe, to provide yourself like a safety net in some sense, is to write characterization tests, which is to say one test for every one of these branches. Okay, go do that for a while. Okay, practice until you're good at that, and then come back to the drawing board and say, I'm a programmer. I automate everyone's life for them. And we meta program. How do we automate our own life? So now the question is, how do you automate the generation of characterization tests? Well, you can use a property-based testing library like FSCheck or HedgeHog. It'll generate a bunch of inputs for you. You pick a large number like 100, or what did he pick? He picked like 10,000 or something. It was a very large number. Maybe it's 2,000. Yeah, I think it was 2,000.
Oh, if you're talking about the email example, yeah, that was about 10,000.
Oh, that was 10,000. I think Mark's was 2,000. You just pick, or 200. You pick a very large number, and then you say, yeah, I hope that covered all the cases, like all the branches. The thing is like we're getting, with so little work, we were able to achieve, definitely 80% of the effort for like almost no input because we use some awesome tools like this. Okay, so now I've heard this called gold master testing. Gold master being the name of the thing that you like trust, like it's like the crown jewels. It's like the copy from which other things are declared, like the reference. Like it used to be the case that a kilogram was based on a particular piece of metal in some special building. Like that's the gold master. Like we base all the other measurements off of this one thing. The phrase
so
Mark uses in this
is a reference to the final version of software that's ready to release to manufacturing. So like back when they stamped out CDs, like for a video game or whatever, that's the gold master.
I see.
So just to give a bit of etymology there.
Yeah. I didn't know where it came from. So Mark calls it a test oracle. I prefer this term. This is more familiar to me as a former theoretical computer scientist. It's like I know what an oracle is. So a test oracle is to say the test oracle tells you what the answer to the test should be. Like you're testing some function and it has some output and you're like, I wonder if this output's correct. The oracle tells you if it's correct or not. In the simplest case, the oracle gives you the answer, so you just compare them and they're equal. In the most like simplest case, you give the output to the oracle and the oracle tells you yes or no whether it's correct or not. You'd have to give it the inputs and the output, of course. Okay. So this gold master testing, which Mark didn't use this phrase in his post, and this is where Alex is definitely better than me. You write a test and you put it, I don't know exactly, I've never done this. Alex has done this. You put it into some state where it knows that it's going to generate a bunch of inputs and then use some function, which is the test oracle, like which is the test in question, right? Because we're trying to characterize this function that we were given. So it generates all these inputs, and for each one of the inputs, it gets the output from that function, and then it writes all that data to a file. Then you save it, commit it, and everything, right? Then you can start changing the function, and you can test it as a parameterized test, given all of the data you serialized. So you serialize it back into the code, deserialize it, you pass in the inputs, and it should still be equal to the same output, assuming that your refactor was correct, like you didn't change behavior. You were just trying to clean up the code, trying to understand what's going on. Does that make sense so far, Nathan?
I'll be honest, not all of it. But
okay, so let me try and repeat it in my own words.
Go ahead.
Then. So let's say that we have usually characterization tests or golden master tests, the two are synonymous in my mind, are done on legacy code. And so this type of technique was described in a book, like Maintaining Legacy Code by Michael Feathers or something. I'm getting the name roughly correct. And what
working
you do,
working effectively with legacy code.
yes. And he has a cute definition for legacy code, which I'll just repeat here because I like saying it over and over. Legacy code is code that doesn't have tests.
I like that.
So if you're writing, if you wrote code yesterday and it's not covered by a test, you wrote legacy code. Anyway, so you have a test and it potentially might be nice and hairy and touching all kinds of weird stuff, and it's uncovered by any tests. And so what you do is you write a test feeding that method random data. Now you serialize that random data into a file. You're saying that, hey, I am going to give you, we'll say 1, 2, and 3, right? And then you write 1, 2, and 3 to a file. The test then, or your method then spits back at you 4, 5, 6. You then also write 4, 5, 6 in a file. And so now you can imagine like 1 goes to 4, 2 goes to 5, and 3 goes to 6 in some type of file somewhere. You save and you commit that to your version control. Now you can refactor that code as much as you want. And as long as it still gives you 4, 5, 6, given the inputs 1, 2, 3, you know that you probably refactored correctly, and you don't have to like worry too much about correctness. Now, the reason it's called a characterization test is because you are describing the shape of your code as it is. You're characterizing it, and you're comparing it to the golden master, the copy that you originally had one commit ago. It does not say anything about correctness. So if the previous code had a bug in it, your new code will still have a bug in it.
I see. I was missing that part.
It will only tell you if your refactor is indeed a refactor. And so going in and saying that, you know what, I want to fix a bug in my code, now suddenly my characterization test is failing. Why? Because your characterization test has inside of its test examples, hey, that bug. And so you might need to like rerun your characterization test and generate some new outputs not after you fixed a bug. And so as a matter of like stack rank ordering, unit testing is still vastly superior to characterization testing. But characterization testing does have a place in this world.
So. Yeah, and I don't know I can't think of the scenario off the top of my head, but I was just thinking, if you know, in all my tests, I generally know the answer. And so as long as as long as my code is giving me the correct answer, I don't care what the character is, right? I care what the correct answer is. So I would be interested to know more about when characterization tests make sense. And maybe it's when you don't know the right answer, but I can't think of that scenario.
I have some code to show you, or at least I can't show you, but like spaghetti code. No one likes like trying to like, why is this method called this? And it's mutating the state of its input, and why on earth would you do that? And it's just blowing my mind. Like trying to make correctness preserving transformations is really hard when it comes to.
Okay, let me lay this scenario, because what you said I think makes sense. What if
I like calling it behavior preserving transformations?
Yeah, that actually clicked with me. So what that means to me is I have some legacy code that doesn't have test, or maybe not enough test. And I want to change that code, but I'm not going to break it because I don't know who wrote it and what on the earth was going on in their head when they wrote it. Okay. Maybe it has some other thing over here in the other side of the code. So I'm going to take a snapshot. I'm going to call it a snapshot of the current character of the code. And then I'm going to refactor it and then make sure that my snapshot, or make sure that my new code matches the snapshot. Because in that case, I don't know the right answer, or I don't understand that I'm not thinking of all the right answers. So
Yeah.
in that sense, yeah, refactoring legacy code makes total sense.
I don't practice TDD, but I absolutely love the mindset behind it. It's these three different perspectives, these three different hats you wear as a programmer. You start conceptually with the red hat or something, the red case, where you try to make a failing test. And once you have a failing test, you're supposed to make it pass with production code in some minimal sense. So there is the step where you're changing behavior of your production code. Once you have all the tests passing, in particular this most recent one, now you're allowed this optional refactoring step. I really love the idea of when I'm making changes to the code to think to myself, is this change to this code meant to preserve behavior or meant to change it? And you can imagine forcing upon yourself a discipline where you only have commits that either preserve behavior or change behavior, but in some sense don't could, like, in the same sense that you can separate pure code and impure code. And of course, if you have pure code, you can add if you have impure code, you can add any pure code to it and it's still impure. So in the same sense, if you've got any commit which changes behavior, you can add any other like diff or commit with it which doesn't change behavior, and the two together will still change behavior. So there's some sense in which it's hard to be precise about this, but it's like, or another way of saying it is try to make your commits that do change behavior to be as small as possible by making your commits that preserve behavior to be as big as possible. Now how do you know if your commit preserves behavior? Okay, the shortest, like most direct sense is that you've like practiced and you study like what kind of transformations are you allowed to do. You try to make tiny changes. But the compiler will tell you if you made a non-preserving change because it might not compile. The tests might tell you that you made a non-preserving change because one will fail after it was previously passing. And if there's not enough tests and you want more tests to help you make behavior preserving transformations, you can generate a bunch of tests using this characterization, this automated characterization or gold master testing approach to help you.
Are we going to try and go back to the row testing?
Okay, so first of all, the row, you asked me what is row problem. It's a made up word for the idea that some code is hard to test. It's not
an
interesting.
RHO, like the Greek letter RHO, just for the people listening.
So it's not it's a name that doesn't mean anything. So Mark is basing his post off of one he read by Hello Wayne. So this guy is writing like in Python, and this is a dynamic language in particular. It seems to be the kind of language where you can easily run two instances of your code at the same time. So he uses some Git magic to have like two copies of his function under test, like the code he cares about. And for the one, he uses it as his test oracle, his gold master. The other one, he changes it and makes sure it still has the same behavior as the other one. In this case, you can actually you don't have to like pre-find a bunch of inputs and output pairs, save them to a file, then change the code, then compare it to what you saved in the file. You can just continually generate it. Like live unit testing is a thing people like today too, where it just will like automatically be running your tests constantly in the background. You can set such live unit testing things to just, especially when it's a property-based test, to just keep running this test forever. Like you keep using, my computer's on using a bunch of cycles anyway, the CPU sitting there doing nothing. Just keep trying more and more inputs while I write. Like just put it, really niceness, like good niceness level, like low priority. So what Mark Seaman points out, not specifically as I would prefer, is that this is not so easily done in a statically typed language like .NET, C#, F#, because you can only load like one version of a DLL at a time. So it's difficult to have like two, just syntactically, it's difficult to have two copies of the same function, like, or again, one copy and then you've modified one, but it's like otherwise the same name and the same namespace and everything, same assembly. So that's why he went with the like generate the data before the input and the output pairs, send them to a file, read them back out. And this is like this Goldmaster characterization type automated version of such things. At the very end of the post now, he says, it would further be interesting if somebody could figure out how to do shrinking. Because when Mark does it in his way, where he has the input output pairs, he can't shrink now because he no longer has the oracle to, like when you do the shrinking, it's like you're binary searching through a space, and based on whether a value passes or fails the test, you go left or right. You can't do this if the test oracle can't tell you if it passes or fails now. We only have a finite set of values for which the test oracle gave answers to. So my idea is that we would encapsulate the test oracle as some piece of executable, like binary, like compile the thing. And then we would make calls to it during the shrinking process. But of course, as soon as you have this idea, you think, well, why did I spend any time saving input output pairs to a file in the first place? I could just have done that the whole time. Just now it's like Hilla Wang was doing in Python. I could just always have my gold master as a binary sitting here running tests. Now, of course, you might wonder how fast it is, and I have no idea. Hopefully it's still pretty fast. The other thing you might be concerned about is, are you suggesting you commit this binary into your repo, which is like something people don't typically like to do? Okay, on first order approximation, yeah, commit it to your repo. It's not gonna be that big. Who's pinching the bits here? Like, I'm not worried about the bits. I'm worried about my time is expensive. The other developers' time is expensive. The amount of like disk space and network IO that's used by this binary file is like nothing, okay? Mark Seaman has a post about this too, where he talks about like just saving your NuGet packages right into your repo. Okay, so he's also on board with this. It's like no disk space used. On the other hand, I think it's actually not necessary to commit it long term, right? If you want to make some refactor, this could be your workflow. You generate the test oracle as a binary. You start to refactor the function, and your property-based test is checking with the test oracle that you're not making any mistakes. And I'm saying you could commit this if you want. Like, you could commit just the change to the binary if you want, or you can just let it sit in your working tree, like not committed, right? You make your refactors. The property-based test with the test oracle is telling you that you didn't make that you were making only behavior preserving transformations. Then when you're done, throw away the binary now and commit the changes, assuming that you are okay. Like, of course, you might want to keep it long term, but it's not necessary. If people really feel strongly about not committing this binary into source, then just keep it temporarily and then throw it away.
Did you take issue with Hillel's, I'm mispronouncing his name, but whatever, implementation of what he did in Python, like the git work tree, I think is the command. Did you not like that, Tyson?
I don't have a problem with that.
Oh,
Mark,
okay.
Mark suggested that approach was only possible because it was a dynamic language.
I mean, if if I were to do this for HedgeHog.xUnit, what I would do is I would pretty much do literally the same thing and then go to the command line, do .NET build, pump out a DLL, call it like up into a folder called like HedgeHog.xUnit2, and then have my meta test runner, the code outside of either project, then like target both folders and say, hey, I'm going to run a characterization test on y'all.
Yeah, I think of this as the same as my idea.
Okay. And so that would allow us to not have to include binaries in our Git repository. But as you said, like bits are cheap, so don't worry too much about it one way or the other.
The point is just not to commit like if you don't want to commit it long term, then don't, but you can use it short term, like in your local branch or something.
Yeah.
The difference between our two suggestions just now are space versus time. I was suggesting that you could only ever have one copy of function at a time, like in terms of the source code and everything, but you would compile it to make this like encapsulated version, this executable. And then I think of it as moving through time to the future. And now you make changes to this function, the same source code that was just compiled to this executable. for to be the oracle, the test oracle. And now your property-based test for the same function would like make sure that you're preserving behavior. Whereas what like Wayne and yourself are doing is like actually making 2 copies using the git worktree command. So this is like two copies in space. At the same time, there exists 2 copies in space. And I'm saying I think of it as I had 2 copies of the function at the same point, like in the same spot in the source code, but through time. Where I took a snapshot of it using a binary, like a compiled code.
My mind is going through the ways to implement the meta test runner right now. And so like I'm imagining like if I were to give it some type of GUI, I would have it like on the left-hand side.
Who wants a GUI?
GUI.
No. I'm saying who wants a GUI? Like, don't make it hard, man. Like.
Okay. Well, like I'm trying to envision it for the listener, right? So like on the left-hand side, you would have like some type of file directory. You double-click around until you find the DLL that you want to provide the golden master copy. You then like open up the DLL. You look at the different types inside of it, and then you would navigate to the method that you are trying to say that this is the golden copy. And then on the right-hand side, you would navigate to the same method in the other assembly, in the new refactored assembly. I'm sorry, when I say assembly, I mean DLL. So being a little bit more concrete here. And then say like, this is the target test code. And now HedgeHog or FSCheck or whatever will come in and throw random data, either of them, until something bad happens.
Okay, and then here's my most recent iteration of like how I envision this. You write your single property-based test with it, not property-based. The point is it just executes your function. In some sense, it's like a test, and it takes 2 ints in, and then you call your function that takes 2 ints. Like nothing's going on, like almost nothing's happening here. Your test, whatever your function returns, your test returns the same thing. So it's just like a wrapper around your function. You decorate it with an attribute that means that this is going to be this characterization style test. And now when you run this test, the first time you run it, it'll check to see if the compiled test oracle exists in the magic place it puts test oracles for functions. It'll find that it's not there, and so it'll create it. The second time you run it, it'll check again to see if the test oracle for this function exists in the magic place it puts them. It'll find it, and so instead, it'll actually run the thing just like your property does now 100 times.
Okay, yours is way better than what I came up with. Yeah, I like yours.
That's why I wanted to share it. Well, in my mind, the hard part is like, is using reflection, given like a function, a method, like a test method. Mm-hmm. How do you essentially generate like an entry point? It's like I want like in reflection or like MSIL or something. I want to generate IL, which is like a static main class, like a static class with a main method whose arguments match, like the list of arguments matches what this function needs and everything. Like, I don't know exactly how that would be done. It's possible though. There's nothing fundamentally blocking it. I think it's a call the compiler or something, MS build. I don't know, something like that. That's something like that should work, but I don't know the details.
Well, after you guys are both gonna comment, I assume, your ideas.
Yeah.
So we may have to have another quick discussion on how that went and maybe what the thoughts were. Steve,
quick, dude, this conversation was supposed to be half an hour.
It's all right, I can break it up.
Good luck.
Well, speaking of this conversation, how about we wrap it up here? Do you have any other important thoughts that we need to share, or should we just go through our closings?
I think closing's fine.
Yeah. Well, thanks for taking the extra time to explain some of those things to me. I really appreciate it, and I'm sure that other people will also appreciate it if anyone ever finds our musings important or interesting. I know I'll definitely re-listen to a lot of this because I want to hear, Tyson, your explanation of Oracle and what was the other thing you explained?
I explained a lot of things.
The golden master testing or whatever. Yeah.
property-based tests.
Yeah. I'm gonna probably listen to those again and again and again. Also, I am now motivated to make my code more pure so that my tests are better.
I can send you a link to a really good video by someone who was using FSCheck to do some property-based testing. And I
Cool.
think that's a fine usage of FSCheck. And like honestly, since shrinking doesn't really come into play with serialized characterization tests,
Mm.
it's fine to use FSCheck.
Okay.
HedgeHog also works, but you know.
I'm also going to spend some time reviewing the property-based testing because I actually haven't done that before. So I'm more interested now, and I want to start writing more F# just so I can use property-based testing.
You don't
Yeah,
have
so
to
I
use
don't
F
think
sharp though.
Oh, really?
Yeah.
For some reason, I thought that was a F# thing.
yeah,
You
I don't know
can
if we're
think
gonna have
of
show
it.
notes or not, but you might want to put the link to the video I'm going to send you in the wherever
Okay,
they
cool.
might be.
Thanks.
You can think of property-based testing as coming from the functional programming community. So in that sense, there's better support for it in the functional languages. So for example, in F# HedgeHog, there is
Winnipeg.net user.
Sorry.
in F# HedgeHog, there's presently a PR that a collaborator has contributed to make the interopt with C# better. There was
good.
already some interopt with C#, but like there was some pain points. There was some like rough edges. So he's making it much better now.
Okay. Well, I think with that, I'm gonna go ahead and wrap things up here. So thanks so much, guys. I'm excited for next time.
Yeah, looking forward as well. Bye, everyone.
Bye.